everybody. A very warm welcome to all of you. Thank you for being here with us today to celebrate a remarkable milestone of the fifth foundation day of C-DAC Patna. It's an exciting moment as we all look back on our achievements and look ahead for being bright future lies before. Without further delay, let's get started to kick off our celebration. I invite to Extreme Director Sir Ritesh sir, Vivek sir, and Kunal sir to join us to lighting the lamp.
या कुन्देन्दुतुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासनहारधवला या शुभ्रवस्त्रावृता प्रभृतिभिः या वीणावरदण्डमण्डितकरा सा या श्वेतपद्मासनहारधवला निश्या शस्त्रावृता प्रभृतिभिः या वीणावरदण्डमण्डितकरा
We are honored to have us an inspiring leader who has played a key role in the growth and success of C-DAC Patna. To formally begin our session, I would like to invite Sri Aditya Kumar Sinha, Scientist G and Director of C-DAC Patna, to deliver the welcome address. His leadership and vision have been instrumental in driving innovation and excellence of C-DAC Patna. We are excited to hear his thoughts and insights as we gather here today. Please join me in welcoming Sri Aditya Kumar Sinha to the podium.
I'll do it from my laptop. Yeah. So, honorable guests, esteemed colleagues from all the centers, friends, my dear friend Dr. Jagjit Nanda from Stanford University, who has kindly agreed to deliver a talk on this very, very momentous occasion of fifth anniversary of C-DAC Patna. Good morning to all of you. It is an honor and privilege to stand before you today as we gather to celebrate a remarkable milestone, the fifth anniversary of C-DAC Patna. We started in 2020 during the COVID time. Now we have traveled a long journey and we have established our metal over the 5 years, and then it's due to the kind of support given by everybody who were the part of this particular journey. The institution has been a pillar of innovations, research, and technological excellence, playing a crucial role of shaping India's digital transformations, research, and of course, development and capacity building. Over the past 5 years, here, Chirag Patna has made very, very significant strides in high performance computing, artificial intelligence, cyber security, drone technology, digital twin, and several cutting edge domains, making an indelible mark on Bihar and the nation. The journey so far, what we have, which begins as a vision to build a center of excellence in advanced computing, has now evolved into a hub of knowledge, innovations, and industry academia collaborations. Our dedicated researchers, engineers, professionals have worked tirelessly to develop state of the art solutions that empower government agencies, businesses, and the academia. In these last 5 years, we have witnessed a groundbreaking research in AI, machine learning, quantum computing, uh, one of the major area on which we are working, contributing immensely from C-DAC Patna side. High impact project in e-governance, healthcare, and cybersecurity. Capacity building and skill development was one of the kind of expertise what we had, and then we have extended, uh, taken a lot of initiatives enabling future ready talents for the nation and in particular for the Bihar as well. The strategic collaboration with industry and academic institutions was there. We have multiple institutions, not only from the engineering institutions. We had MOU with the agriculture university, MOU with the what you call MOU, MOU with the what you call AIMS, the medical institutions, and we are taking doing the joint research with them. Looking ahead, the future of technology in Bihar and beyond is a kind of our focus, and we step into the next phase of growth. Completed 5 years, the responsibility before us is greater than ever. We must now continue to strengthen India's digital ecosystem through indigenous research and development, promote AI and high performance computing for societal good, empower MSMEs, local industries, uh, particularly in Bihar and other regions of the country, particularly in eastern regions of the country, with transformative technologies and enhance digital literacy. We have done enough for enhancing digital literacy on different aspects, skill development for the youth of the country. That is again the kind of focus we have been giving for the next, going to give it for the next 5 years plan, but we are going to make it. So a heartfelt thank you to all of them. Uh, this kind of journey was never been possible without the relentless dedication of our team, the support of entire C-DAC fraternity. Okay, every member of the C-DAC has some way and others have contributed to this journey. The faith on us by the Director General, the corporate office, our own ministry, Ministry of Electronics and IT, the government, the other agencies, the industry partners, Department of IT, Government of Bihar, who have provided us the seed funding to start this particular center, our mentors and associates, and trust placed in us by the community. Okay. Today is not just about celebrating the past, but also about charting the future. Together, let us reaffirm our commitment to innovate, excellence, and nation building through advanced computing and digital transformations. So here is so many years to success, impact and technological leadership. Thank you, and let's celebrate the occasion with pride and enthusiasm. Thank you very much.
Thank you, sir.
So moving forward, we are extremely honored to have with us today Dr. Jagjit Nanda is a distinguished scientist and executive director of the Joint SLAC, Stanford Battery Research Center. He is also an adjunct professor in material science and engineering department, Stanford University, and a scholar at the Stanford's Precourt in Energy Institute. Dr. Nanda is an internationally recognized leader in the area of battery and energy storage materials, with emphasis on the beyond lithium ion chemistries, solid state, and grid scale energy storage. He is a fellow of Electrochemical Society (ECS), Materials Research Society (MRS), and National Academy of Inventors. Now, I request Jagjit Nanda sir to kindly give their his insights.
Hello, good morning, everybody, and thank Aditya for inviting me to this talk at a very short notice. I just arrived from India yesterday evening, so I may look sleepy or jet lagged. My apologies. But it's a wonderful opportunity not only to touch base with the old friend, but also glad to see emerging areas of research developing in relevant topics related to AI, machine learning, and application. domains. So I am not a AI or machine learning person, but I'm a domain expert. So who want to utilize the advancement on many multi-scale modeling and AI deep learning methods, neural networks, all part of the same kind of study to make batteries and energy storage efficient. So in today's talk, I would like to give a flavor of how a institute, since Battery Center was inaugurated just 2.5 years ago, it's called a battery accelerator, and you can think C-DAC as also an accelerator or an institute building up to accelerate the pace of the technology and science. So I'm going to give you a flavor of how do you rapidly build an institute or accelerators that is a part of the ecosystem, what are the ingredients, and then I'll give you some example specifically today how you can make batteries faster, safer, high performance, enabled by AI and machine learning methods, supported obviously by physics-based modeling and experiments. So with that, let me first spend first of my talk about um, that I want to see. I want to see if my slides are okay. Great. So looks like my all right. This is great. So I want to really jump forward to tell you where we are and what we do. The Venn diagram here is basically where the battery center is located in the heart of the Stanford. Its ecosystem is one of the best, I would say, the location in terms of having an impact. And I'll give you a few examples. So this battery center is a part of the university. It's also a part of a federal lab, which is also a part of university. So we have a national lab, which is connected to Department of Energy for doing research. It's also within the Silicon Valley of Stanford where a lot of innovations happen. So every companies is only headquarter of the companies is only 5 miles to 10 miles, whether it's Apple, Google, Yahoo, Tesla, you name it. So we meet those innovators and industry leader all the time. Our students work there. More recently, Stanford has opened a new school called Sustainability after 70 years. And the Battery Center is part of this school. We also had Energy Institute. Why I'm saying all that? Because all these things matter for having the impact because we have resources and the ability to make an impact in battery science and technology. So I would suggest that here, how do we differentiate ourselves from the rest of the centers? One may say we have centers all around in the world on batteries and energy storage. But based on our own research, we found out that connecting science to technology is good, but to solution and back is very critical. What does it mean? What it means is all institutions in the world, IITs and all the leading institutions do great science research and they develop technology. And this technology happens, then it becomes a startups and you just license the IP to startups. But that's not enough for the success of those startups and the new companies. You need to have a solution mindset. That essentially means you need to identify the big scaling and manufacturing problem, deep science problem that these startups or companies are facing, and bring it back home to solve using a multidisciplinary team. That's exactly called the revolving door model, which is the way to go in the modern time where technology has become very complicated, and also you have a lot of manufacturing and scaling problem happening, especially in energy storage and battery science. So we have already a very good playground to play. So what we call the deep bottlenecking scientific question from Silicon Valley. These are the battery companies that started from Stanford in last 12 years. And this is key because some of them have become big companies, some of them are on the way for becoming public, some of the way are just small. But it gives us an ability to go to these companies and ask their CTOs and the technical team, what are the bigger science challenges we can help you? Because they cannot solve their own problem alone, because it needs a multiple discipline and people to solve it. So we bottleneck the scientific question and use it in the center. Staff and scientists and professors work on those problems to identify solution to these things. I'll give you many examples in my talk today how we do that. More across is one of the most important aspect that we have is people. This is just a snapshot of the professors from different department, the scientists from the national laboratories with different domain expertise in energy storage and batteries who are part of the centers. What we do is we identify the experts that you need under one roof. So they are all under the battery center. And then we, depending on the sponsor, depending on the solution, depending on what the multidisciplinary scientific problem we could solve, we have a combination of these people who are X-ray scientists, who are material scientists, synthesis, polymer, data scientists, multi-scale modeling, ceramic engineers. These people have multiple expert synthesis people, AI and machine learning people. So we have this team to address this problem. So the reason I presented this model is because this is how we are uniquely positioned to attack the next generation problem with speed and scale. The speed and scale matters. Technology and science will not wait if we don't have the speed and scale and the sense of urgency. That's where we matter here to accelerate deployment of new technology, helping industry to attain that because they don't have all the resources to do that. Same thing that company as the institution like C-DAC in India with MIT and other can help industry to attain or solve the problems of the emerging problem which they being business driven cannot do it. So basically our mission is very simple. What we do is to understand the deep science or to establish new battery technology curves required to electrify transportation and grid with speed and scale. So we want to invent, we want to accelerate, we want to deploy new battery technology curve, new battery chemistries, and learn from that experience how to accelerate that for transportation and grid with speed and scale. For example, when we talk about grid, let me connect you to what you guys expert. When you say about energy storage for grid, cyber security is a big issue. Reliability and resiliency of grid is a big multi-scale AI-driven method of like cyber security. So each of these things have basically connotation to modeling, prediction, lifetime, life cycle analysis. All these things can be done with the help of the new high performance computing, high throughput computing, and I'll give you some example of Gen AI methods to solve deep material science problem or deep battery problem as I move along. So again, what does success looks like for us? Because once you have a center with so many investment and people, we have to clearly define our mission, which I just spoke. We also want to show how the success looks like, and this is very important for us and to our sponsor. Now, when I joined, I draw myself in a single sheet of blank these two graphs, how fast we can scale and how much we can scale, which is cumulative gigawatt and cost is the common axis. Now, for example, if you're developing new sulfur or sodium chemistry, which is competing with lithium ion, for example, I'm not saying naming, everybody wants this will be a parabolic curve or sort of pseudo exponential like this. We need to scale faster and also have the technology mature faster. So the slope of this cost versus scale is the learning rate. That's applicable to any of your domain technologies. How fast you learn, because each of this area has different component, and each component, how many percentage you learn every year. That's the learning rate. And industry and the market defines a cost floor. So you can see there is a trajectory between the tangent, which is the learning rate, and the cost floor defined. And this is pretty, whether you are working on solar technology, whether you're working battery technology, whether you're working on any of these pretty standard things, um, mm, how you do it. Now, as you developing the new green technology or new green curves, you're always competing with incumbent technology. For example, in terms of battery storage, if green is the new sodium ion, which is a wishful thinking and it's a good R&D problem to have because sodium is earth abundant, but you are always competing with the current technology, which is the lithium ion, which is also becoming very energy efficient, cost efficient with time. So you expect, as I told in the right hand curve here, you expect that at some point your new technology will exceed the incumbent one, and that's when that can happen, where it can really switch over or transition. So that's exactly what we would like to make it happen. So how do we contribute? How do a research center, whether it is Stanford Battery Center here or a C-DAC center in Patna, how can you do? Now we can always help working with industry to define the cost floor. We can do good techno-economic analysis. We can also help teams to understand and engineer complexity. We can address the scientific roadblocks to adoption. And then, more importantly, we can work with industry on innovation and process and scaling with speed. So, in this way, why I'm making clear that our role is very defined, very structured, and quantified. Most of the institution research who have been there for a long time, I don't see, there is some mission, but I don't see the granularity. I don't see the objectivity. I don't see the sense of urgency and the tools and methods that you need to solve the problems, societal problem or a research problem or emission problem or energy problem, either way. So, so one example I want to give you before I go back to the domain topic here is one of the center that is really doing right now is comparing orange to apples. Now, if you want to compare orange to apples, you cannot just compare on a similar scale. You have to do or apples to apple or orange to orange comparison. Now, the question is, everybody is asking when I back to India that we all want LFP batteries. And then the second question they ask me, will sodium ion able to compete? Now, for a layman who is not used to battery research, this cartoon is very important. You can see the LFP graphite here. You can actually, it's dimensionally very important. You can see this, the size of the battery cell scales. That means for the same energy density, you need a bigger volume here for the sodium ion. That essentially means sodium ion is less energy density. Now, energy density is cost and volume. So this gives you a very important parameter for developers, how to really compare a emerging, a mature technology which is becoming cheaper and cheaper, like LFP graphite, with something which is emerging, sodium ion. Now, I may not go into more details. This is how the center does. We don't do anything on our own. We do with the community. What we do is we go to the specialist. Our team goes to benchmark minerals, Wood Mackenzie's, a standard potential mining company, and get the supply chain analysis. And on the right hand side, we work with industry like Bloomberg and Avishin and Wood Mackenzie to get the market adoption forecast. Now, then we work with all the stakeholders, the companies, get their feedback into our techno-economic model. In that way, our model and road mapping becomes really quantitative and really risk averse. What you can see, the green thing here is how the lithium ion, the LFP price is going down. And the yellow thing is the forecasted sodium ion prices with all the uncertainties. Now, where does this uncertainty comes from? It comes from your left and right hand analysis, where what is the projected cost, what is the projected supply chain analysis, what is the projected market cost, All these things have gone behind the model to have a forecasted sodium ion price. So you can see very clearly that next 10 to 15 years, we don't see sodium ion at all becoming competitive to LFP. This is exactly based not what we say, but where the community is convinced because we work with everybody and get their feedback and projection. Now, something that I want to tell you what are the grand challenges of scale. So, one thing that the center is trying to address is how do we design storage chemistry from sustainably extracted materials that enables manifold reduction in cost floor. This is a very big grand challenge of scale because for the grid scale storage, we need gigatons of material. Maybe lithium is not sufficient enough supply or recycled lithium is not. Maybe we need like tens of gigatons of material for grid scale storage. So that essentially means we need to work with very earth abundant elements. This is exactly where situation like Bihar and Odisha comes into picture. We have a lot of manganese and iron and other resources. So the question is, can we design high performance chemistries from sustainably extracted materials? And that's something which India can do very well because they don't have to depend on China for processing of lithium ion or anywhere else because a lot of these earth abundant materials can be utilized. And I'll tell you how AI and machine learning can accelerate these discoveries. This is directly into the domain of your expert. This is exactly where you are doing in many domains. And this is exactly why aircraft industry is so successful in predicting the properties of aeroplanes or nuclear industry. But in batteries, we have not really successfully able to predict, design, and validate materials and manufacturing processes, integrating atomic, stick, mesoscopic, and device scale. Basically, as you know, if your model has the granularity, if the model has all the right ingredients of incorporating all the atomic and mesoscale information, and then goes in a way of predicting property, that will be much more robust and accurate than just empirical or some purely modeling based. So basically, this is from how do we go from materials to devices to system, predict cost, predict life, predict performance. And for that, if you want to do prediction and validation, you need great models that where you integrate across all scales. Another problem, you can see a lot of batteries catch fire. And catching fire, all the safety issues is a big thing. The safety science is also very important. Many times safety is just an engineering fix. People realize that after they make the battery pack and they put some engineering solution. But our center faculties are really trying to understand safety from a fundamental side by developing fire retardant electrolyte, by understanding really methods to see how the dendrites growth doesn't happen in batteries, so catching fire, how the graphite lithium plates on graphite using very advanced techniques. I don't have time to go, but I wanted to give you an example of speed and scale of battery technologies where AI and machine learning can be an enabler with domain to energy storage and batteries. With that, I switch gear. Please feel to jump, ask me question or raise your hand and I'll happy to make it more dynamic if needed. But then I now switch back to something really deeper into the domain after giving the broad stroke of how the center works, what is the goals and ambitions, how does it operate, what are the mission, and how the tools and techniques and the people who can enable this. I think same model works for any of these institutes that you are running in India or world abroad. So this is a very deep, this is a very mm, thought-provoking slide. Battery science and technology is a multidisciplinary. Depending on where you are and what is your domain expertise, many things can attract you. For example, when I go and talk to a Tesla engineer or a Tata Motors or Mahindra engineers, they are not bothering what happens at molecular scale or atomic scale, or they may not even do the mesoscale thermochemistry or electro. They will ask that Our pack life is this much, our calendar life is failing, our degradation is happening, thermal runaway is happening. So they work at an engineering level. They work in years. But somebody who is working in IITs and Indian Science or anything, they may be working on fundamental particles and fundamental interaction and designing new chemistries. But the question that I'm putting is that each scales needs to be connected for the complete value system. And the right hand side, the tangent here, all the modern techniques that you need to probe to collect the data, to collect the diagnostic feature, so that you can put it into the modeling domain. So that's how you have a length scale of the technology, you have the time scale of the technologies, and if you want to a holistic approach, you may be a domain expert in some of the areas, nanosecond, femtosecond, and maybe working in these fundamental atoms and cell level, but you are required to have the knowledge of the overall at the system level to integrate your science and knowledge. This is very important to put into that practice. Where is the battery technology roadmap going right now from next near term to uh, long term? Now we are using earth abundant chemistries, getting rid of cobalt and nickel. We're trying to work on silicon. We want to work on earth abundant materials, even an iron based and manganese based. AI and machine learning method for predicting battery life and performance. That's something is really is a hot topic, which we call battery informatics. And we also work on some long range chemistries of energy density, like how work on lithium sulfur batteries, lithium metal batteries, solid state batteries, battery recycling and refining and extraction. So these are the really important areas how the technology roadmap is bent from near term to long term. All right. Now let's go where the rubber meets the road. Now I would like to the reason why energy and AI are related is the following. As you know, as we go to GPT-3 and beyond, the NVIDIA chips are becoming very energy intensive. This curve tells you that ask us ethical question also, that searching and referencing costs so much energy. When you search in your Google cell phone or something, it equals only a small amount of energy. But inferencing, when it's able to ask you question, it goes and computes something somewhere in the cloud and brings you back, that cost energy. That's why the data centers, that's why the NVIDIA chips are becoming so energy things. It's going to be prohibitively expensive, and also energy demand will skyrocket exponentially as given in the right thing here, based on the neural network model or neural network over time, energy required. So that essentially means the GPUs must be made very energy efficient. Sorry.
No. Sangeet sir, kindly mute yourself, or host, please mute the other people.
Okay. So
Sorry for the inconvenience, sir.
no problem. So again, this is exactly something which I'm sure Aditya and his team must be looking at that.
স্যার আমার সাথে স্যারও গেছিল আমার সাথে যেটা গেছিল
প্রায় 30 বছর পর 27 না 28 বছর পর আমি মাঠে গেছিলাম।
All right, so I hope it's muted right now. So this is exactly how we start exposing to this method here. Then there are some questions to be just not following blindly just because AI and machine learning is right now the mantra and everybody is trying to do. We need to a deeper understanding the limits and boundaries where it can be used. So there is some of the questions that you need to ask. So for example, there is already exist a lot of data. Can you use the existing data right now instead of going after big data and efficiently use those raw material? For example, 10% of the raw scientific data is collected is used in publication. mining already existing data is maybe key. So basically, these are the things that we need to ask. Broader question is the AI machine learning appropriate for everything, or it has to be case by case that we need to use? And probably the answer is the later here. So before going into deep, what we call the inverse problem using AI and ML, my focus right now, I'm not, even though I'm not AI ML expert, but I understand the implication, understand the material system and domains level, the performance. So in my mind, being a non-AI and non-computer science domain, which is use algorithm experts and all this neural network modeling, all those deep learning methods, autoencoders, and all these things, which I have only peripheral knowledge, but I can really see how I can collaborate, how I can work with AI experts and machine learning expert. Let me give you an example here where I can really be efficient. So traditionally, there is a call a bottom-up driven. Mostly the AI and machine learning methods are applied for material discovery and predicting physiochemical properties. You have material genome. You can predict new material with new properties using descriptors, and you have a hierarchy of descriptors built in with complexity. For example, in matter of domains of batteries, discovery of new solid electrolyte and electrolyte design for redox flow battery. There's a lot of work which has come out where they can do permutation and combination of all the electroactive materials and the electrochemical window and their properties, electrocatalyst. That's very important. More importantly, I'll spend most of my time, the rest, talking about significant advancement in using AI and ML in predicting battery life and degradation. That is also very important to the Indian context. Well, I just spoke in the Delhi with Niti Aayog. I told that the tropical climate like India, where there's a lot of humid and high temperature, the batteries are really degrading little faster than other parts of the world. So when you bring cells from other countries, how do you make sure their warranty is 10 years or 12 years? It may be 8 years because of the climate. And that's exactly where we can use some of the machine learning methods to predict life under ambient tropical condition, under tropical climate condition. Now, there are a lot of autonomous laboratories have come up everywhere, robot driven, based on some ideas and prediction. They have high throughput methods to really self-driving in a loop using autoencoders to really generate a lot of possibilities and then restrict those based on the machine learning approach to find the end output, connecting materials to the properties to the system. This is called the closed loop inverse design problem. We are using this kind of autoencoders, which are basically deep neural network algorithms to do that, compete. Now, so, uh, but this is where the existing current state of the art, a lot of experts are working on this, and still the field is evolving. But I'm going to challenge you to work on new areas and opportunities, which is even more complex, more hierarchical. For example, how do we have the dynamic model depending on the grid demand? For example, in the daytime when the solar is there, you rely less on your other sources. Nighttime you need demand on the battery storage. So this dynamic modeling in smart grid is is very important. How do you include grid cyber securities? So bridging from materials to policy is where all kinds of complex inverse problems where AI and ML can work at a system level. And that's the challenge. That's the emerging area. The sooner the countries can do that and integrate this, they are the final winner of this in this area. I'll give you some example, continue this example, what we have already done or going to do using this machine learning and Gen AI. You can see that how this arrow gives you how a bridging across the scale using AI and machine learning. You have chemistry at the material scale, fundamental materials discovery, structure, property correlation. You take that knowledge domain to a battery cell level where you predict the estimation of the battery health. life prediction for the cell level. And then you take that to the life cycle management, recycling, system level diagnostic. So you can go from a chemistry and material scale to a device scale to a system scale, bridging across the scale using these methods for better prediction and ultimately from cradle to grave. Example, there are so many success already in literature and few other things that I'm going to highlight today. Electrochemical performance predictions. You can see, I don't have to explain everything. X-ray computed tomography. What kind of mesostructure and internal tomography a electrode has for efficient ion and electron transfer. You can generate a lot of these patterns and then using a descriptor and a what you call a discriminator set, where the discriminant all the synthetic data will be then fed into a machine learning guided descriptor and a discriminator. The discriminator will just guide you where the exact output needs to be and rejects all of the things. So out of all the tomography and all the 3D architecture, the thing that is not realistic are all filtered away. And then it gives you a lot of synthesis data, which are very useful to generate. That's the Gen AI. You can predict similarly 3D microstructure. You can also use that information for degradation of the materials because the change in morphology in the science. So, so the bridging across the scale, as I said, the inverse design methodology empowered by machine learning aims to close the loop in material development cycle. So what you can do previously in tens of years, you can do in half a year because you can close the loop using these autoencoders, using the GNI methods, and then come up with very faster solution from materials to system. Here, if you want to do it successfully, you have to bridge the interface between domain experts, people like me who understand batteries at a system level, at a cell level, chemistry level, materials level, fundamental level, to domains of AI and machine learning, so that I understand what are the limitations of the model. I understand the physics of the model, but I'm not good at running those model or really work on those algorithms to generate meaningful results. So I'll give you some more ideas. How do we go deep learning based image segmentation? One example that can be very important to solid state batteries and what are the preferred microstructure. How do we use the imaging and tomography and generate those microstructure or tomographic patterns and realize and then filter out a lot of realistic transport where ions and electrons can move facile and then come back and then connect it to at a system or a cell level. So basically, it's the image analysis, whether you are doing electron microscopy, scanning for microscopy, where it can see the topography, morphology, you generate all the lot of this data, and you also predict those features or patterns that you think is close to the reality. And then you then compare with real architecture or propose new architecture based on this knowledge, guided by experiment. So this is also very important. And this is exactly how this is done. This is at the nuts and bolts. This is where I'm not an expert, but I can tell you, you can generate a lot of FIB, ion beam cross-section of ACM images, and you generate unrealistic cathode and anode materials. And then you have process and augmentation. You generate synthetic training data sets because you want to optimize this. Because what you see on your left-hand side is the experimental not optimized, but basically you see how experiment work and what is there. It may not be the most efficient networking of the electrons and ion, but on the right hand side is a synthetic training data set where based on physics and model you generate synthetic data and then go back to the electrode manufacturing and generate more close to that algorithm. In that way, you get a convolutional neural network algorithm to predict and the efficient microstructure. So now I switch gear. Let me see how much time I have. Okay, so yeah, so now I'll give you some real work coming up from the battery center. Okay. Um, so basically, the data-driven prediction. So let me give you a flavor how we do the research. The question here, this paper asks you, can we have a chemistry agnostic approach? Can we have a data-driven approach? We don't understand. We don't want to understand the battery chemistry. Can we just use data-driven small data set, not huge data set that will come unsupervised one, but I'll tell you a supervised one. How can you use a data-driven approach which is chemistry agnostic so that you don't have to go to specific chemistry of the batteries? I'll tell you this particular work because it's very interesting. What you see in the top curve is they take a lot of cells, real cells, and do a fast charging from different charge, from 3.6 to 6C, but at one particular discharge. So you can see there is a long range of this capacity fade here. On y-axis is the discharge capacity, and x-axis is the number of cycles. The question is why these 124 cells have different discharge profiles. That is because they have been randomly charged at a very high rates. So when you charge at a very high rate of a different cells for a long time, their cycle life is affected because although this is discharged at one rate, one particular specific rate, but this shows degradation because they have been charged at variable rates here, 3.6 and 6C. So if you zoom up this into first 100 cycle, it looks like there is not much capacity degradation. But the question is, do you need to wait for 1,000 cycles, 5 years, 3 years to do that? Of course, this is fast cycle, so you can do it even few months or 6 months. The question is, do you need to wait that long to predict the life of batteries? The answer is no. All these things this slide does is to have the correlation coefficient between cycle life and discharge capacity and measures the correlation coefficient, the spread, pretty much normal statistical things you do. But the bottom line is that can we be more clever? Because this is maybe a dumb way of working that you have so many spread in the data and then you see that different batteries are this same chemistry discharging at different rates because they have been charged continuously with different algorithms. But the question is, you don't get much estimation of how to combine life, predict life. But let's change the physics now. Now, when you transformation from one descriptor, the previous descriptor was only capacity, discharge capacity, cycle number, and some analysis. But then we go to a different descriptor, a different mathematical transform. We said, okay, instead of looking at the capacity decay, why don't we see the voltage curves of each of the cycles and take a difference, delta, variance of the delta charge. So basically what it shows is the discharge capacity 100 and discharge capacity 10. Basically what it does is it takes this data and flips it over in a mathematical form, voltage versus capacity. And then you can see the changes in features here. So basically I'm telling you that we are mathematically transforming a descriptor from voltage current to a derivative or differential capacity. And when you do that, you can start seeing early failures here. You can see this is an outlier here. This portion in the red is outlier. And you do all the statistical regression. So the point I'm driving is, how do you build your descriptor in the early cycling stage can tell you a lot about the battery's future use and the life if you can have the right mathematical transform or right physical attribute done, not in the usual brute force way. So this is a very simple example how can improve the prediction from early cycles by doing a mathematical transformation of your physical measure observables. This is a physical observable, but just transform in a mathematical sense. Another great work that has come up working with Toyota is AI optimized 10-minute fast charging here. What we have done here is basically we said, okay, so as you know, when you fast charge batteries, the capacity degrades since faster. So we want to build an early outcome predictor and then have a machine learning approach. It's called multi-arm bandit algorithm, MAB, and which is very interesting. What you do is that we first figure out what is early outcome predictor. Is it the impedance, electrochemical impedance? What is early? Uh, and then we use that as a training data set and we bin this into different parameter space. One is higher certainty, high cycle life. So we bin this training data set into different multi-arm algorithm, and then we optimize those pieces and feed it back again to the battery cycling procedure and then for the first 100 cycles we optimize then optimize the machine learning algorithm to make it better and better. So this is where what can be brute force done in 600 days, this model can do in 16 days. That basically we saved 2 years effectively, less than 2 years, which can do in few weeks. The only thing that we need is algorithm obviously develop, but the first 100 cycle of the descriptor to optimize the fast charging, and it saves company the money, the warranty, and prediction ability than waiting for number of years to do this actual waiting for the data. Then going more detail into how can you use measurements with machine learning. This is a very exciting work that's going on, that where we can really take each particle of a battery material and then tag this particle how they fail using descriptors. This is done by this. You take the raw data using X-ray synchrotron or tomography. Then we machine label these particles based on their volume. So these are on the right-hand side, surface, crack, detachment, shape. And then you have another set of descriptors with position, E-density, state of charge, neighbor. So what we do is if you want to predict failure, our raw data can get machine labeled based on how they fail by the color code. And then each failure mode is identified as a matrix. The volume, surface, crack, detachment, shape. These are called particle features. And you synthesize all of these to have a failure prediction model, which is very sustainable. So I would, I think I am going to end today, and yes, so that I have some interaction and Q&A with the audience here, so that mm, and have ready for any questions. Can you hear me?
Yes, sir. To conclude this insightful lecture, now I will invite Commander Vivek Kumar Yadav, Scientist E, C-DAC Patna, to share his thoughts.
Let us have some questions. Maybe if some audience would like to ask some questions.
Hariharan, I can see Hariharan, somebody has a
Yeah.
question.
Right, right.
Yes. Sir, am I audible, sir?
Yeah.
Yes.
Yes, sir. Thank you, sir. First of all, thank you for the presentation. In fact, to be very honest, the complete presentation was very comprehensive. I have, based on that, I have a couple of questions, but due to the interest of time, only one question I'll ask, sir. In one slide, you are mentioning about this, fast charging and all those aspects.
Right.
So I'm trying to link that with this modern day commercials, wherein this all the smartphone manufacturers, they are telling that 0 to 100% in 30 minutes, 15 minutes. We are
Right.
developing gallium nitride chargers and all. I mean, according to you, where it will go in the future, sir? I mean, once we had days where a mobile takes usually, 5 hours, 6 hours, or sometimes in the night we used to put the charge, in the morning it used to reach 100%. And
Right.
now in this 10 or 15 years, we have reached a stage where 15 minutes charge is more than enough. I mean, there are a lot of things basically happening in battery technology. Probably
Right.
what I think is it started as a kind of a convenience, but now things are going very faster manner. So what is your opinion on this, sir?
So the battery costs are reducing. Okay, that's number one. The consumer behavior, they want a lot of application. They don't want their battery to die in next 3 4 5 hours. So what you see is we are using high energy density chemistries right now, like lithium cobalt oxide with graphite or NMC with graphite chemistries, high energy density batteries. Obviously all cell phone has. But what is more important is they have designed. So batteries are two types: batteries designed for energy, battery designed for power. So, but this increasingly these mobile phones, there's a trade-off between energy and power. So more and more, because of the customer demand and the prices of batteries are going down, and you can pack more energy per unit volume or mass. So what is happening is they can make it both high capacity and also high rate. That's number one. Number two, they can also optimize the BMS, how the load and supply and BMS for efficient charging, and for they can then have chips that can charge without degrading the life. So all this algorithm, as I discussed, are built in so that you can charge faster without degrading the chemistry.
Okay, sir. Understood, sir. Thank you, sir.
Yeah, good morning,
Uh,
sir.
can I say something?
Of course. Of course.
Yes, sir. Yes, sir. So,
Okay.
Ashok, sir, we'll take Ashok sir's question first. Yes,
Yeah.
sir.
Thank you, Professor Nanda. It was very interesting and latest technology involvement, in fact, particularly the battery life and the charging technology advancement in terms of the utilization of the latest AI/ML provisioning. That itself is a combinational solution. Probably this will definitely help us in future, so that people can make better developmental activity and the practices. I was just thinking of just one particular issue, like for the automatic vehicle systems, there the kind of the provisioning for this effective automatic switch on off kind of system which is currently available. So can we go for some sort of development in a low cost manner? Like now it is very costly till now, the things which are appearing here in India. So advancement of this technology can give some sort of direction in that respect. You kindly share some thoughts about it, sir.
Automatic what? I'm sorry. Which
Automatic vehicle systems that where
autonomous or automatic?
uh,
Autonomous.
you, you can say that autonomous one. Yeah.
Yeah, yeah, autonomous vehicle is a big area, and lot of these features, EVs are coming with semi-autonomous and autonomous features, and that there are two kinds of autonomous technology. One is sensor based, one is radar based. Okay, and so Teslas and all these things are sensor based, but the radar based are even more accurate and long term. So the question is, the technology is already developed and it's already there. Whether it will be ideal for first of all, it's very value added and high end.
Yeah.
Secondly, whether it's optimized for Indian condition and roads, we don't know. So we need to de-risk that and bring the cost down. But I think it will be a little bit presumptuous to start working on that unless you work on drones and robots and all those things where you can use the same technology. India, what does it need right now is basically not even EVs. We need two-wheelers and three-wheelers or EV, and obviously have a smart grid system to charge. So autonomous vehicle is although a very fascinating area, and a lot of things goes on for defense and other application. For consumer, it can wait in Indian market. We are not yet there because even developed countries are not yet fully operational on that. But it's a good area that C-DAC should work on because it has implication to many other technologies, high-end technologies first. So it will go into very high-end technology before coming to cars.
Yeah. Okay, sir.
Yeah, good morning, sir. I have some question. Actually, one question with a perspective of software, I would like to see battery. So my question is, when battery is in use, do you have so far any mechanism or basically a software intelligence that new generation batteries may be using to manage heat dissipation and their life management?
Oh
Do you
yeah,
want
that
me to do some software to manage their heat in some sense in
it's
future
already
generation
very developed.
batteries?
The answer is the answer is yes. The state of the health of a battery means many things. The SOH, state of the health. So there are many sensors are there who can detect early thermal runaway. Basically, it can be at the cell level, and then if they are at a module level and a pack level, most of the safety feature software in the BMS at the module level and the cell level, if there is one or two cells are bad, they have isolation circuits which they will then reject those cells because they don't want these cells to be a stumble in on, or if the temperature goes a little bit more non-linear in one of the cell, they have isolation. They isolate that. So there are really all level of models available right now, cost efficient. For example, Tesla uses 8,000 cells, 7,000 cells. So they are all cooled individually, but they have nice isolation circuit breakers. If one of the cell fails or have some safety issues, they immediately isolate that from the module so that it doesn't spoil anything. It's an old saying in India that one rotten potato will spoil the whole potato, so they don't want to do that.
Thanks. Thank you, sir.
Good morning, sir. So, in one of the slides, you mentioned that we are using AI for predicting battery life and degradation. So, in the backdrop of the recent fire incidents on some e-vehicles, so can we or do we use AI in for real-time prediction or alarm system?
Not yet. What the OEMs, the company wants their cells to last longer and also some abuse testing. Right now, it's not dynamically monitored. It is monitored dynamically on board, yes. But right now, a lot of the effort is predicting life and safety under the automotive duty cycle. Um, During onboard, uh, I am not sure. I'm not an expert to say if in some high-end cars there's already AI chips running to really monitor safety on board. But I know there is passive safety involved. If in BMS, as I said just before, if one of the cells catches fire or heated more than required temperature or close to thermal runaway, they know how to mitigate that.
Okay, sir.
So, does anyone have any other question too?
Yeah. Yeah, we have one question.
Okay.
Good afternoon, sir. Sir, I have a question. How we can overcome the raw material shortage for lithium, cobalt, and nickel?
I just gave the talk last week in Kolkata and in Varanasi. Um, you need to figure out smart recycling, and that's really at a very nascent stage. Only 5% of the battery or 7% of the batteries are only recycled. But the recycling has to be cost effective, so a lot of work is going on right now. One other thing is, as I didn't talk about, we develop active materials that has no cobalt and nickel. We can work with manganese, we can work with iron, earth abundant materials. And sodium ion was an example where in future sodium precursor, sodium soda ash and others are not so expensive.
Thank you, sir. Do we have any more questions?
If time is there, I have one small question. Can I ask?
So can we go with this question as well, sir?
Yeah.
Okay.
Yes, sir. Sir, actually, this question is a follow-up to the one who have asked previously. Sir, currently we are working in drone technology, sir, and the main challenge when we face while optimizing the drones is the battery weight. Of course, there are n number of factors, but battery weight is something that we are really worried about. Ideally, what we expect is the battery should be very as thin as possible, and it should give as much endurance as possible. So, can you suggest some of the technologies or any vendors, or in India especially, who is working in this cutting edge battery technologies for drones, anything like that, sir? It would be very helpful for us.
Well, there are companies who are working, some startups. So I don't know what stage of technology they are. So what exactly you are looking for? Can you repeat?
Drones with, I mean, drone batteries with, the weight should be very minimal, but giving a much good discharge rate. I mean, longer discharge rates specifically.
Right.
So that the aerodynamics is getting optimized, then the drone can fly for more hours.
Right. Yeah, so that's pretty fundamental, and but we are working some high energy density chemistries, which is not yet very mature. For example, solid state batteries or lithium metal batteries. But the problem, they can have 450 or 500 watt hour per kg. But the question is safety, and then we cannot discharge that high rate yet. So we have some technology barriers right now to solve before we can have that lighter batteries. Lighter battery means high energy density. So it's almost double or nearly double of current lithium ion, but it's still not commercialized at scale.
Okay. Thank you, sir.
So same for aviation also. Batteries for aviation, or NASA and other, they want aviation batteries. They want to hybridize aviation battery. That's another area.
Thank you, sir.
Yeah.
Yeah. Thank you very much that you have given us time and then very intelligently brought in the battery technologies with the AI and all. So my takeaway from this the kind of lectures you have delivered here, I don't understand much about the physics and chemistry of the batteries and materials of the battery and all. But you have in your talk you have mentioned about the AI techniques which can revolutionize the battery technological through. So
Right.
one is maybe the battery management system. People have also asked about that real-time monitoring, predictive analytics, optimizing the charges or discharge cycles, whatever it may be. Overheating, another area of concerns, and how to extend the battery life. Predictive management is always be kind of a focus. And of course, for the research perspective, you can see that we can have a battery chemistry innovations. We can do it through AI, accelerating the discovery of maybe new materials, chemical components, and maybe leading to more efficient and long lasting and sustainable battery solutions. These are some of the aspects that we have. In fact, in the energy sectors also, like we can transform through AI. Important is also, I can see here out of your talk, though you have mentioned that you have not much of those kind of things in AI and machine learning, but you have very aptly put up the points around that, the synergy between AI, batteries, the energy, optimizing energy, particularly the storage part of the optimization and all, where we can develop AI-driven algorithms for storage efficiencies. Then we can have a EV battery. EV is kind of thing which is getting popularized in India as well. So we have EV battery optimizations and all. smart energy trading. We already had a meeting in my meeting, and they wanted to have smart energy trading kind of things. How can do it through the AI-based system and all. So in the future directions also we can see that if maybe we have a chance to further interact with you that battery recycling, how we can do it for AI-driven battery recycling kind of things. We would like to work towards that. Uh, AI-enabled smart homes or microgrids, how we can optimize. So all those things are kind of the takeaways for all of us who are into the technical domains on AI kind of things, and looking forward to have a kind of interactions further on, continue with the interactions, or maybe looking forward to have become some kind of joint proposals and joint workings, where we can take care of the AI and other aspects of the technological things, and the core knowledge is coming from your side. But I'm looking forward to. Thank you very much.
Wonderful. I hope
Uh,
it was.
Vivek, you can
Yeah.
Yeah.
Good afternoon, sir. Sir, I'm Commander Vivek Yadav. I am Joint Director here at C-DAC Patna. Sir, as we all are technocrats, we are united by our passion for innovation and research. And as you know, sir, today marks the 5th foundation day of C-DAC Patna, a significant milestone in our journey. And there could not have been a better way to commence this celebration than with an enlightening lecture by you, sir, Professor Jagdeep Nanda, distinguished scientist and executive director of the SLAC Stanford Battery Center, Stanford University, USA. So we extend our heartfelt gratitude to Professor Nanda for his insightful talk on emerging trends in battery science and technology. His deep dive inside various aspects of battery technology provided us with a comprehensive understanding of how the entire ecosystem has evolved in the USA. So your discussions on the scalability of technology over time and the techno-economic competitiveness case study was particularly thought-provoking. An aspect I think we all must consider in our research endeavors. The role of AI in accelerating research is well known, but its revolutionary application in material science, as highlighted by you, sir, were truly eye-opening. Sir, your multi-dimensional perspective on battery science, technology roadmaps, and emerging opportunities in AI and ML will surely guide us as we explore battery and energy related technologies further. Furthermore, sir, your insights on data-driven modeling for predicting the behavior of complex systems provided a valuable framework that we at C-DAC can learn from and possibly implement in our own research. We sincerely thank Professor Nanda for his valuable time and efforts in sharing his expertise with us. Your knowledge and guidance have inspired us, and we look forward to applying these learnings in our future work, sir. And we certainly will have you next time whenever we'll be facing any challenges in our research work, sir. Thank you so much, sir, and good day to you, sir.
Thank you, Vivek. Bye. Bye from here. Good night from here.
Thank you, Nanda.
Thank you, sir.
Thank you, sir. Thank you, sir. Moving forward, I would like to invite Shri Aditya Kumar Sinha, Scientist G and Director of C-DAC Patna, to deliver his lecture on technology impact and transformation and humanism. Over to you, sir.
Thank you very much. Let me. This was actually originally we had planned a lecture by somebody from what you call art of living, and person was supposed to deliver a lecture on technology and spirituality. Okay, and I found these are the very very apt topic for today's world we are living. A kind of accelerated developments are happening. Since that our Sri Sri Ravi Shankar ji is here only, so he had to go for some. He was not able to come for the lecture, so I thought to fill up this gap, I would present something. Particularly, it's more on the philosophical side, and let me see that how we can take this forward. And the topic which I have chosen is basically the technology impact, transformations, and humanism. That is the kind of humanity and the humanism is the kind of very very interesting to me nowadays, and I'm doing a lot for study and philosophical kind of queries, how to define those kind of aspects and all. So let me first have a slide presented here. Let me try it out, and then we'll start the lecture. Yeah. What is yeah. Yeah, I'm audible now.
Yes, sir.
Okay. So let me start with this very, very. Oh, it's again, it's visible, not visible.
Yeah, it's visible, sir.
But this is visible. Oh, before starting, before going into the my presentations, let us have some of the very profound questions we may ask from ourselves. Like these technologies, we are being affected day and day night. So, how this technologies personally transformed your life? And do you see it as a positive or negative changes? Anybody who can talk on this? Can technology truly enhance human values or does it risk replacing the essence of human connections? What ethical responsibilities do innovators and companies have when developing transformative technologies? And we have conducted a lot of digital transformation programs, but how these digital transformation programs are empowering people rather than making them overly dependent on machines. Is there a point where technological advancement should be limited to preserve human dignity and identity? These are some profound questions that is there with the advance of the or accelerating technologies. What is today we are dealing with? We have a more to deal because we are in the technological domain doing R&D. So more responsibilities are there on us. And that's why I thought this presentation, this kind of talk would be very apt for everybody in C-DAC who are dealing with the technologies day and night, day out. This is the kind of environment we are living today where kind of technology is very, very exponential and it is going beyond the kind of uh, the kind of the comprehension level of the human being. human being is a very simple entities where we have a lot of positivity as there, engagements are there with the communities there, communications are there, relationships are there with each other, with the nature, with the society, with the self relationship also with the meaning is we always look for a very, very deep meaning for ourselves about the nature, about the everything. And we also become very happy where some accomplishments are coming to us. So these are the some of the nature of the human being, and through the interventions of technologies, how far we are able to cope up those kind of accelerating technologies. This is the story what I'm talking about the people like us and we people from C-DAC and those who understand technologies very well. But think about the people who are who are actually not conversant with the technologies and how they are trying to cope up with those kind of aspects, and more importantly, how they are their kind of thought processes, the way of doing things are changing with those kind of acceleration which is happening around us. So when you talk about a transformation is having a multiple aspects. Okay, a multifaceted aspect. Transformation means from one form to or state to another across various domains. That is called transformations. Okay, and I tell you, transformation we have engaged with transformation in many like being a kind of study the science and then other aspects. So we have been encountered with the transformations like so mathematically, if you can say that transformation is a process of changing the shape, size, and position of a geometric object. That is a kind of transformation. For example, we can say translation is a translation is a transformation that moves one object from one location to another. While reflection, if you can talk about reflection, which is basically a transformation that flips an object across the line of plane. So these are the some of the activities we see in the mathematics, physics. We already have seen about energy or matters, uh, water freezing in ice, multiple forms of water. So transformations happening. Technologically, we have digitalizations, and digital uh, uh, we can transformation, which has already been happening. Uh, Analog data to digital formats. All those things are the part of a transformation. Biologically, we have evolved from amoeba to the Homo sapiens. Genetically modifications, continuous genetic modifications in living organisms happening. So these are the transformation which is there. In fact, psychology also we have a lot of personal growth, reshaping belief system, attitudes, behavior, and as we continue with the time, we have things have changed. If you can evaluate yourself, you can see that 10 years back, what was your thought process, what was your thinking process, what kind of belief system you had, and what kind of attitude you had, and how you have changed over the time with the experience you have taken in interacting with this world or the technologies. So these are the some of the important connotations on the transformation side, and but it is very critical and catalyst for the progress. If transformation is not happening, progress will stop. It is also shaping the information, innovations, development, and human evolutions. Transformation is very, very important aspect to deal with. And that has been there. Transformation, not the kind of story which is we are talking today. Uh, it is happening since so many years. 13.8 billion years ago, we had a Earth with a big bang and all, and the dumb and matter like no, you can say the lifeless matter has turned intelligent from there onwards. Then we have 4.5 years around billion years ago, uh, Earth has born. Uh, then we have this, like, as a human being, we can, if you talk about, we were the kind of insignificant ape, okay, just one animal, and which becomes the ultimate ruler of the planet Earth, the human being, the Homo sapiens. So, how technologies help human to become ultimate destinies of intelligent and consciousness? That is also important aspect, and how the transformation has happened. Uh, then we have this. We have a long history of the human societies, and we have seen that agrarian revolutions almost 10,000 years ago has happened. We have started the family system. Okay, then we started living in the group community. So those has been there in, as per one estimate, 10,000 years ago. Uh, the first impact on information technology, which has been created in 1440 AD, that is a printing press. That was the first information kind of, progressions or revolutions, what has happened during that particular time. Then we had 36. I was just reading that one article that in India, that in 1936, the population was around 35 crores. And now we are living in this in this country where the population is almost 1.5 crores. And world has moved from 2 billions to 8 billions as per the estimate. Uh, so transformations are happening everywhere. Okay, transformation for the good, for the positivity, transformation for the kind of greater responsibilities to the people who are supposed to uh, kind of, kind of develop uh, best out of that particular transformations. That is very, very important. So when I see about the technological transformations over the period of times, we have to be see that the transformation happening in waves. It's not something which is transformations are in technological transformation is to happen. uh, the kind of acceleration which is happening today, it used to happen in the waves. Early waves, the technology has been used by the human for the purpose of their to support the muscle power, to augment the muscle power. And hence we had in early ages, we have axe, shovel, floor, knife, all those kind of things were being used as a technology to, as I mentioned about the strengthen our muscle power and all. We move to the next wave in around late mid 19th century, and then we have coal powered machines which has come the pictures and all. So coal powered that is used for strengthen our kind of activities. Then moved on to the electricity, oil based energies, electricity based energies. Then we also have created a kind of individual machines. Okay, like cars and all, cycles, all those things are, or sometimes, have a machine powered uh, kind of things which help us to do the things in a faster pace. Okay, and where human operators are working. So we moved on to another next age, where next wave we have riding on the next wave, where we had automations all around, uh, algorithm centric applications development, and we have tried to overcome uh, the human operators. Okay, more automations, less human operators. Okay, then we have moved on to the next level, and that level, fourth energy, where you tried to integrate ICT into the uh, system. And moving forward, we had kind of, earlier is to have this augmentation from the technology was your muscles. Okay, your kind of, but now the augmentation is on your cognitive activities. And that is kind of, something which was very unique, because human being has been taken shape in this earth, on this earth is basically, and they are excelled in their cognitive abilities. And we are now having a system or technologies which is augmenting your cognitive abilities. So that is something very, very new which has happened. And the consequence is that the kind of the technological evolutions has now been accelerated, and people have started working very fast on the technologies. What you have seen couple of years back may have a lot of changes today. And another important aspect which is coming up, which was, we have witnessed that the kind of, the walls between the various domain areas are actually melting, and we have started working on the multiple domains in one go. So whether it's information technologies or the quantum computing, uh, space technologies, yesterday only we had talked about the energy solutions. The energy solutions can be isolated from this computations or AI-based system or information technologies. It has a common goal, common objectives. So these are the some of the things which we have seen over the period of time, that the boundaries, the kind of walls between which is uh, separating the different technologies and different domains are melting, and people have started jointly working towards on a common goal and common uh, achievements. So these are some of the changes which has happened. And now, and this is the one very good slide I had prepared. I have just copied, I think, from somewhere. It's basically talking about a new world where uh, the average what you call living, longevity of a human being in America, that is the study has already been done, that uh, 70% increase in longevity of the average Americans. So that has happened. So right now we have like in India, we have a retirement age of 60, and say in India it is almost 80 is the kind of, the average age where the person can live. So we need to understand that what they do after 60. Okay, that is an important question we have to ask. Then we have smart machines and systems are taking shape, augmenting and extending our own capabilities. So how to utilize those kind of things? Too many things are all around. How to manage those aspects? How to manage those machines? How to manage applications? That's another aspect which is coming to the picture. Uh, we are in the computational world all the time. We are the kind of consumer. We are the kind of, uh, raw material for the information technologies to progress, the AI to progress. So how in this in the computational world we are going to live with, where we are expecting a lot of sensors all around of us. Uh, so we have now this that we call somebody call it a mathematical world, somebody's called algorithmic world, some kind of people are calling it programmable world. So these are some of the concepts which is coming to the picture. New media ecology, we have now been earlier is to tackle text-based kind of system, music kind of system. So multiple medias are now taking shape. Now we have this visual, that immersive experiences with the AR, VR kind of things are happening. And we always have to deal with the video, and then we have images, we have text. So multiple things you have to uh, sync with. So multiple media literacies beyond text, we have to actually master the art. We may be able to do so because we have been experienced as things are moving. But there are the people who have been not been trained on those areas, may have been finding it very difficult to cope up with these kind of scenarios. You can have elderly people at home. You can see that how difficult for them to handle all those multimedia, multi model communication kind of aspects. Then we also have, if organization level, we have a superstructure organizations. Okay, uh, we have now people are talking about. You have seen that after the COVID, people have started working from home. So the structure of the organizations are changing. People are no more there in the institution itself. They are operating from anywhere in this world, and that gives rise to a lot of competitions for with everybody and all. Every corner of the people can compete with the other corner of the people of the world. So that are the kind of things which is coming up. Socially connections are enhancing. So those are the things which is there. Then we are also into the globally connected world. Everybody understand that, where diversity, adaptability is the center of operations. another important aspect is coming up, like, we don't know that if you're interacting with somebody and who is responding from other end, it's a man or the machine. So that kind of environment we have to live with. So, so these are the some of the challenges we have to deal with. But before going to the how we can deal those kind of things, let us understand who we are. We call ourselves a human. Still, I found myself as a human being, uh, but in extended format. Okay, what I was there 30 years, 40 years, 50 years back. Today, I have a little change. I do things a little different way. So this is the human we have right now, and what is the kind of future what we have. So let us first fundamentally try to understand what we are. What is a human? So human is species of highly intelligent pyramids that inhabits in the earth. So that's everybody's aware of that. And they are characterized by the upright postures what we have right now. Okay. So we can see through the long distances. Okay. Opposite thumbs like this, which will help you to hold the tools, because essentially the human beings are the tool users. Okay. To substantiate or to augment our physical abilities. We also have, being a human, we have brain size is larger relative to our body size. Okay, and complex social structure, very very complex social structures we have created over the period of time. So that is the human being what we are today, uh, capable of a wide range of activities. uh, the other animals can do very limited activities, but we can do a very wide spectrum of activities. We have languages there, we have a sound, all those things are there with the animals, but we have very very different languages we can talk and we understand with each other. And culture has been developed, art has been developed, science has been developed, technology has been developed by the human being. Another aspect with the human being is that we have unlimited capability or capacity for learning and creativity, which are not there with the animals. And we have the ability to reason, okay, comprehend the things and all, solve problems, and from abstract concepts. When you talk about it's like technology has come very late, science has come first. In almost 1,000 years back, science has come. After that, technologies have come, but before that only the philosophy was something more very 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 abstract. But as a human being, we are capable to abstract those concepts, the philosophical aspects, and basically the reasoning that who we are and what we are supposed to do, what are the kind of ethics, what are our culture, all those things are the part of that. Uh, we are the human being, we are deciding the fate of this world, basically the nature. Uh, you have seen that a lot of good and bad. We can talk about that how we are doing that, how we are ruining the nature. But we are the people who are influencing the nature mostly. Okay, impacting the ecosystem, influencing the planet's climate. So we are that kind of people. And overall, human is complex and fascinating species with many unique qualities and abilities. So this we define ourselves. Okay. These are the capabilities inherently come when we have been evolved as a human being, Homo sapiens and all. Uh, Over the period of time, technologies are getting influencing us, the digital transformations are happening, how we are going to change, how we are changing ourselves, how we are trying to excel in those kind of circumstances. That is the kind of concerns, and that's why I'm dealing with this particular subject. Uh, so as I mentioned, that we are co-evaluation evolution is happening with technologies and the human kind, the flood of data, what you see here, the algorithms, the computational power. Uh, we have Moore's law, everybody understand that. Even we are going beyond the Moore's law. We are now working on technologies which may have infinite capabilities like quantum and all. So the human and the society interactions also changing. You have no seen that you have social media, social institutions, the networks, all are working very differently. Economics are different. Uh, it was earlier that what you do in your state uh, had a consequential effect within that state itself. Now things have changed to the nation, transcending beyond the nation, and something is happening or some government change is happening at one country. The effect is happening at another country. Some war is happening, breaking out at between two countries at some place, uh, some another continent, but impact is coming to our country as well. Political structure has already been changed, and political structure has been very widened. Okay, widened. Look, we have a multiple aspects in has come into the political structures and all. So these are the some of the changes which is transformations are happening due to the technologies what we see today. Uh, for many tasks, the machines surpass already what human can accomplish in speed, precision, every analytical detections. Like machines are widely being used, the robots are widely being used, the algorithms are widely being used, and which is sometimes some of the applications is surpassing the kind of the accuracy, speed, and even analytical abilities what human can comprehend today. So these are the some of the changes which has happened. Uh, when we have to have a another aspect, now people have started utopian thoughts and dystopian thoughts are coming up basically, that technologies, whatever we are delivering basically, so they should be good for the human, okay, and can align with the human values. That is very important. Our aspect, we are dealing with the technologies and we see that we can, and we also the researchers, we are innovators. So we always try ourselves to try new things and new objectives to fulfill. But always you have to have a kind of, back at the back of the mind to have a kind of a thought process that whether I'm developing a technology which is aligned with the human values and needs or not. Okay. So this is a very important aspect. And people have started talking discussions on in various forums that the technology should enhance, not replace human interactions. That is very important. We have seen that how human interaction, the physical interaction has been reduced over the period of time. So how technologies can be utilized so human interactions may not be challenged. So these are some of the major concerns what we have when you talk about the humanity and technological transformations. And then we need to have to understand the humanism. What is humanism basically? That is my one of the area of philosophical concepts I'm trying to demystify. Okay, so a progressive philosophy for ethical living, personal fulfillment, and responsibility for greater good without reliance on theism or supernatural belief. That is the humanism. Okay, what do you call it? Well-being for all. You know, Indian philosophy system, what you want to talk about. So it's called that Sarv Bhavantu Sukhina, Ahimsa, Vasudev Kutumbakam, Dharma. All those are there in us since so many years of kind of wisdom which was there in our country. And so now these kind of talks are there, that these kind of things are getting challenged, and hence we have to understand that how we can protect those kind of core values, compassion, dignities, uh, harmonious world where we have to live in, and we have to see this universal well-beings of everybody, and informers universal well-being to guide human progress. We have to progress. Everybody has to progress. You have to transform, but it should protect our being human capabilities. That is the kind of objective we have to work with when we are developing the technologies. We are engaging ourselves in the kind of innovations, the research. We have to see that. The another area which is coming up is called digital humanism. In fact, I had the opportunity to give a couple of lectures on this kind of topic, and now I have seen that a lot of universities are establishing a center of excellence in digital humanism. In fact, I had an opportunity to interact with Sri Sri University in Bhubaneswar, and where Sri Sri himself has established that a center of excellence of digital humanism in his campus. So this is something which is coming up very, very differently, and we have to understand there's some philosophical aspects, some technological aspects which is coming together, and some psychological aspects are coming together, neural aspects coming together, and that is called digital humanism. Uh, is a notion that people are the central focus in the manifestation of digital business and digital workplaces. Very, very important understanding. See, we need to talk on those aspects today. That need has arisen, has come up. So we have to discuss. We have the various forums that people should be the central focus on in the manifestation of digital, anything digital happening or digital development, digital transformation happening today. Then technology should enhance, not replace human interaction. That's already I have told you. And I take you to some other level. In fact, some of the questions I would like to like to ask today. Are we more intelligent than the evolutionary process that created us? We have come out with as I mentioned, that we are from amoeba to the Homo sapiens, the form which we are today. This evolution process of 4.8 billion years, and are so are we more we if the evolution process which have created us, are we more intelligent than that particular process itself? That's the question we may have to ask, because we are the people who are making this AI happen, the machines which can be operating today. So are we creating more intelligence than what the evolutionary process of 4.8 billion have done? This is the profound questions that you have to ask to understand that people have said that the AI is going to kill the humanity and all. It may not, but we have to challenge, we have to argue on that, we have to debate on that. We have been created, the intelligence which has been created within us has come out after 4.8 billion years. Okay. Are in a very fast or 10 years, 20 years, 30 years, 100 years down the line, are we going to create the same kind of intelligence or same kind of machine which is intelligent than like us? People call it as a general intelligence, AGI, artificial general intelligence. So are we be able to create that kind of intelligence? A question being asked for all technologists. Okay. Can intelligence create another intelligence more intelligence than itself? Can I create as a human being an intelligent system which is more intelligent than us? Nobody has an answer today. But people have two thoughts, two word kind of school of thoughts are coming up. Somebody says that okay, it's possible. Some people say that's not possible because again the argument they give is that the intelligence what we have right now is of the brilliance of the 4.8 years. So that is the kind of arguments we have to do. And will the technical intelligence that we are creating comes to exceed that of the creators? Again, the same thing. Uh, that we are creating come to exceed that of the creators. Has created a technology. We have seen intelligence everywhere. Nature is very intelligent. You have the colors, flowers, the patterns, what you see today in nature, flow of water. All those have been created by the nature. The intelligence has been created by nature. Okay. But you know, can we create a more uh, intelligent system? What till now we have seen around that in the nature, is it possible or not possible? So these are some of the profound questions we have to ask, we have to answer. As being a human being, we are the creative people, so we have to ask that. And then another is that uh, things are changing now. The perspectives are changing. Human as a biological and a computable systems. We are becoming more biological and a computable system. Uh, the kind of uh, what we were to yesterday maybe have the different aspect which has been added up to us. We have one extended limb. I call a smartphone as extended limb. Okay, what you have. So what you think that is getting reflected in a mobile phone, and what you see in the mobile phone is reflected on your mind. So those are the kind of aspect which is coming up, and many are such aspect. There's a concept called cyborg, where many people have all the organs have now been be the machines basically. Only the mind is working. Okay, so that kind of three of the, I don't remember right now the names of the people. They have been developed. No, have been um, uh, transformed to the cyborg, and only human like the brain is for them. There's a beautiful movie called Upgrade, where once the person is get after that, his entire thought process of the mind can be uploaded to the kind of the cloud, and human being would be there basically. He can be always interacting with you as the natural being, and but only the body is not there. So those kind of things are already been happening. These natural neural implants. Yesterday also, what Dr. Binde had talked about the Elon Musk Neuralink. It's project where implanting a kind of chip on your mind and then trying to capture your brain activities. Bionic limbs and prosthetics are already is basically a machine which is added to your body. Artificial organs, robotics, enhancements, all those things are being in place. BCI, people are working on the BCI side. So how things are happening yesterday and now, the signals of the brain is getting captured and which can be utilized to further perform certain tasks. So these are the some of the things. And in Indian context, the Indian ancient wisdom is so beautiful. Like whatever we're talking today was actually in some form present at some level. In the Mahabharata, Karna, basically the Kavach Kundal. It was actually biological armor integrations. Okay, that was there with this uh, kind of with Karn. We have many seen many such uh, through the stories. Okay, it has been already been talked about. Mahabharata has written thousands of years back, but they were talking about this kind of human as a biological and computational system that was already been there. Many such stories are being there into the system. People have seen that taking the shapes, changing the bodies, and all those kind of things. We have read a lot of stories. So that being there all the time, the technologies were there in the Indian knowledge system as well. When we talk about the brains and the bodies, we have a kind of with the biology and advancing intelligence, we have a DNA system. You're already aware of that, and how it is getting in a better shape and all. That is again a kind of a aspect that we would think about. Synthetic biology, people are talking about, uh, where designing and modifying biological system for new functions. Right now, a biological system has been meant for some XYZ kind of things and all. So can we have a kind of some kind of a transformation where biological system will adapt to certain new functions and all? They will start working. Maybe replace the activity of other organs and can be simulated to the some other organs. So in that case, some system is not functioning well. So it can be alternative which is been available to you. Uh, Transformation in medicine is happening a lot, and agriculture, energy system, everywhere it is the transformation is happening. Uh, Ethics and social implications are there with the brains and bodies. People talk about that brain can be like right now we have a system where you have a learning system, we have a knowledge architecture, and you just study those knowledge architecture in many forms, like to nature also, to the books, to the text, to the videos, to the images, and you get an experience and make your mind brain, okay, your capabilities of brain get enhanced. Can you have some signal methods? Okay, you can just put up some chip it out there, or come some kind of tools and all. So those kind of things can be imbibed in your mind in a seconds. Those are the kind of aspect which has already been been there in the innovation side, but responsibility is on us that we still have to uh, treat this human being as a human being. Okay. And as I mentioned, that being human, what you are supposed to do, we should remain that way. Otherwise, things would be very much to a different level, and controlling those activities would be very, very difficult. There is a people have a lot of talks about the consciousness and all. Uh, People are say basically hide the mystery of awareness. Conscious basically mystery of awareness. How everybody is trying to understand what is consciousness. Science of consciousness is one of the aspects. How technologies can be utilized to improvise the consciousness of the people. The subconscious mind, all those aspects have been there. Sometimes we do something as a human being to do something out of our consciousness. It has been already been proven fact that uh, you are taking decisions not by the conscious mind. Most of the decisions are taken by the subconscious minds and all. So the consciousness is one of the bigger mysteries what we have to deal with today, and people have doing a lot of studies on this consciousness and how technologies is basically become the part of this kind of consciousness study. Sciences already been defined. They're talking about signals. Somebody talks about the quantum aspects and all. Okay. The quantum basically, the quantum mind, how consciousness are bringing to the structure. So those are the some of the pivotal issues where perceptions, attentions, memory, reasoning are people are talking about. How technologies are being the part of that particular activity, whether we can have a more conscious system, human being can become more conscious, augmented by the AI or the sensor technologies. Those are the some of the profound questions that we have to first try to understand, and then we have to start working towards that. So maybe it's an evolution process. So we have machines which is evolving now, and in a very accelerating rate. So we need to have the human being to evolve also with the same rate. As I have shown in some of the slides out there, that human comprehension is now going low, and technologies are moving faster. So how we can enhance the capabilities of the human being with these kind of technologies, where to augment the consciousness process of the human being. So as we grow, as technologies will grow, we'll still able to comprehend the growth of the technologies. We still be can consider as a kind of next level of human being. Evolve faster. Nature would be always evolving us, but can we do something our own or develop some technologies? We can still be able to develop ourselves faster with the kind of accelerations, the way technologies are uh, getting up. We have seen this communicate like consciousness during the Mahakumbh. Everybody was rushing towards that. It's a shared responsibility and cooperation. You can comprehend this communication and the consciousness with the Mahakumbh, like uh, very temporary infrastructure, tent cities, food distributions, medical aid, but it runs very efficiently through mutual trust and cooperations. Okay, it's a it's basically so many people in a small city. So eco-conscious practice was followed, cleaning the ghats, maintaining a discipline, discipline, showcasing collective civic senses and all. So these are the some of the things which has happened. Nobody has taught that. So what when you have to understand the concept, you have to understand that kind of things, group activity. Nobody has taught everybody that you don't do this one or this is not a kind of template which was given to them. But it has happened. This is the kind of this is the kind of the community consciousness we call it. Okay. Million can act as a single entity, driven by faith, tradition, and deep-rooted sense of unity. Just think about aloud on this kind of activity. You'll be able to understand consciousness very well. Uh, they have the power of shared belief in shaping human behavior and fostering to human society. This is the one. More so is basically like they have a collective spiritual experiences. Okay, dipping into the water, the holy Ganga was giving them like some kind of enlightenments to the mind. that and they're kind of actually realizing their experience, spiritual experiences during that particular time. Devotees from diverse background. They talk different languages. They are from different places, different gender, but unite in faith. So these are the some of the uh, and one more important aspect is self-organizing community. They have already been created. A crowd, you can't say a crowd, but it's a consciousness of the crowd itself, which has act there where no 65 crores of the populations of a country has visited, and in such a small town, you just think about it. If they come to Patna, 5 crores people in a day, how Patna is going to work. So these are the some of the but that's happened basically, in the small city, not even the small district of the Kum. It has happened. So how can we have, like, this is the one consciousness what we have. First, we need to understand those consciousness, but how can in technology be enhancing, and or maybe you can call it digital transformation of the or technological transformation of consciousness. So that also we have to think about. Okay. Uh, then we have to have a already people are working on a brain computer consciousness, that how this computer can or the technology can influence the consciousness activities of your brain. So those are the some of the questions we have to ask. We have to work on that. We'll be able to work. Some of the technological aspect that I can talk about, we have meditations and mindfulness apps or tools are already been there. Um, Okay. And we have virtual reality and biofeedback devices. These enhances, like, suppose you are working with this Oculus or some kind of, AR, VR kind of things, you be the part of the environment itself. So that enhances your conscious activities and all. Okay. Since of global consciousness, social media platforms are creating as a global community. And then uh, see, 10 years back, if you talk about 15 years back, you talk about very people are having this perspective of the global perspective on any aspect. But today we have any of the activities, we have always talked about the global perspective and all. These are the some of the important changes which has come out after this technological interventions in terms of VR, AR, meditations, apps, consciousness, social media platforms, and all. So these are very important aspects. We have to see that how meaningfully you can have plan it out for having a more uh, conscious human being that you have to see. Quantum computing is already been talked about. A very lot of people have talked about that. It's if you understand the quantum computing well, you will understand the consciousness. So that is very, very important aspect which has been talked about. A lot of research work I have seen, and that research work is not for all from the people who are dealing with the technology, dealing with the science. The people are who are dealing with the spirituality, the people who are dealing with the humanity. They are also talking about the quantum things and all, and they are trying to have it that how uh, quantum can be further enhanced to understand the consciousness. So all those technologies, why I'm talking about this technology, because already in some way we are working towards that. But in order to have a better work for the humanity, we have to expand our research goals and thoughts. So next is basically transforming thoughts and technologies. Can technology be able to give you, to enhance your thinking process? I already give the example of full spectrum thinking. See when there is no box. Okay, we will talk about that out of box thinking, but when I call it see when there is no box, seeing beyond the bending corners. So all those things are already in there. How it can that thought process can be transformed, and so we as 600 ideas are the minimum coming to everybody's mind every day. How to catch up those ideas? Most of the ideas are not taking shape. So how these kind of things can be further enhanced through the technologies? Okay, from imaginations to reality, thought to innovations, shaping technology that enhance lives. Uh, we have a mind technology connections, how we can do that. AI and machine learning, how it can be using we used to human mimicking the human thinking for smart solutions. So these are some of the technology. Maybe some of the groups in different CDAC centers are working on uh, in bits and pieces about all those aspects. Like Delhi, I know that Priyanka team is working on the BCI side and all. But we have to expand those kind of things. We have to see the bigger goal. Of the humanity, and then we have to start working towards that. And that's we can only do that because we are the hardcore R&D organization in the country, and we have very strong Indic wisdom system we have gone through. And somewhere will say that whatever has happened thousands of years ago, everybody is having that kind of memory within you. So it's possible for all Indians to actually contribute meaningfully into those aspect, and that's why I'm bringing these kind of thoughts in front of you. Uh, uh, so these are the some of the aspects we have to bridging the mind, innovations, transforming thoughts and technologies. Those are the kind of things can we think of today and start working towards that. So I feel that in this context, this new world, you have to have a very different skills are required. This new world where we have to deal with the multi-modal contents. The collaborations are virtual, mostly people are, we have 10 friends locally where to whom you meet every day, but you have thousands of friends uh, connected you on a virtual mode. So how these kind of things, these are new things for the human being. So how we are going to cope up with these kind of activities? Uh, we have a lot of information that's flowing. Information is very much easier to access. A lot of such informations are there. Some information are good, some bad, some generated by the some of the system, some is kind of uh, created to influence you badly influence you. So all those cognitive think aspects due to the various information coming to you. So how to manage, how to filter out those information. So these things are becoming very important that activity today, that cognitive load management, what information you have to capture, what not to capture, what you have to further analyze. Those aspects you have to see. Computational thinking is another area that we always have to see in terms of the computational part, and always we are talking about transdisciplinary things because now I said that the kind of uh, the walls between the various domains disciplines are melting. So we have to, for any solutions, making any solutions, we have to have a multiple domains coming to the action. So these are the some of the aspect we have to actually talk about, and we have to develop those kind of skills. Sense making, uh, very important aspect that what exactly is meaning. There are certain aspects which is been written within in the text, but there are certain aspects which is not been text. We'll talk about the read between the lines. Okay, so these are the some of the sense making aspect. We are talking about some X, Y, Z, and we have to understand that what exactly is the meaning, because we have this lot of informations are going in one go. Uh, You have to come out with the information paralysis, and you have to still make this sense. So these are the some of the kind of perspective which will be there for the humanism. Is have the human centeredness that all we talked about, empowering the human being, inclusion. Everybody should be the part of the system. Part of humanity doesn't mean only the male, female. It's a kind of entire ecosystem when you talk about inclusion. So entire nature, every living being on this earth, it's our responsibility as a human being to take care of them. Ethics and responsibilities are an important aspect. And of course, creativity and innovations, we have still we have to uh, kind of protect our creativity within us, innovation within us, because right now we have seen that a lot of AI-based tools, technologies are coming up, and that may create a like kind of slackness or some kind of negative effect on the creativity and innovations of the human being. So those are the some of the challenges what we have. So as a final thoughts, we have on digital humanism we talk about is about a social perspective, ethical and social perspective. Ethical means that uh, everything, whatever we do, is for the good of the human being, for everybody on this earth. We have a greater responsibility on us, as I mentioned. Promote human well-being and dignity. Technology aligns with the human values and right. We have a philosophy, sociology, psychology, design, engineering, neuroscience. Uh, Everything is coming together. So from everywhere, for all the domains, you take the insight, and then we have to develop the solutions. Okay, and we also be ready with the continuous conversations. Okay, balancing innovations with ethical responsibilities. I've seen in the world that people have one set of people matters for they'll fight for the climate change. One set of people they see the business perspective more and they don't talk about the climate change that you have already read in the newspapers. So we always have a bigger goal that for this particular beautiful world what we are beautiful universe where we are the part of. Uh, so we have to create a human-centered digital future empowers, respects, and enhances human lives. These two terms, when I was working on this particular topic, so two terms which is coming up, and that's why I just present here as a parallel populations. So refers to a digitally modeled population that simulates real world demographic behavior and decision making process. This population can be used for policy testing. So you have a digital population basically, and we can have a policy. We make with a policy. We can test the policy before actually implementing it for the real people. Social security optimizations, optimization of the resources, all those things can be done using this particular parallel populations with similarly the parallel human being, uh, where AI-driven pick of a real person and where multiple testings can be done, behavioral patterns for the decision-making abilities, mirroring the human cognitions. This can be, if you can able to develop this kind of activities, then we can have like, we have a better healthcare system we can develop for them, better approach for the human we can develop for them. Some part we are doing itself as a kind of thing for a digital twin, what we are doing, talking about. Can we think of a digital twin kind of a structure for this parallel populations and the parallel humans and all? And of course, we're living in the kind of a distributed society and metaverse, which can be implemented using the digital twin kind of system. Multiple use cases can be designed around that. To sum up, and the conclusion, for as part of the conclusion, just have some wisdom which is coming from the ancient scriptures, which are presented here. That so I'm living with this good uh, wisdom which has been put up to us, and these are the kind of part of us. Everybody have somewhere down the line or somewhere in their lifetime have encountered these kind of things. Somebody has been taught them all those aspects, and that's why I'm telling that in this world where technologies are accelerating, we have greater responsibility as being Indian to take to kind of take up those kind of challenges, and we have to evolve ourselves in such a way that we can the accelerations and the technological the awareness the consciousness of the human being can match together and they co-evolve together. So that was my kind of I'm looking forward to have these kind of things, and maybe maybe I have a some way I have just motivated you to look for this kind of very, very important aspect, because you don't have to look only for you, you have to look for your next generations to come. Okay. And if you not think today on these kind of challenges, will not be able to plan it out for the coming future. Coming future is not come to you as it is. We have to design those that particular future. Okay. For our generations to survive in that particular future. That is my objective of this particular presentations. Thank you. Thank you very much.
Thank you, sir. We may open the stage for audience. If someone has any questions, they may ask.
Sir, one just small thing. It was really a very interesting discussion. And in fact, I can remember this particular discussion earlier in CC University also that time. And you have added more this thing, valuable inputs, which will be definitely useful for the future people, like next generation, definitely. Some one important aspects probably in digital humanities would be the inclusion of the language insertion part. That is the language technology adaptation for a human factor improvement and so on and so forth. So in that respect, sir, if you can suggest some roadmap which can be possibly useful for our team and others like who are working into that field.
See, a lot of thoughts are already been there basically at the governmental leader, government level, the UGC level, and all that. Language is very, very important entity, and uh, it's, you comprehend the things better in your own mother language. That is the one fact which has been already been proved and all. But in this business world, you have to have, understanding of the multiple languages kind of things and all. So really in the language side, we have enough work. We have done it. Pune, you have already done it. Kolkata, so you are contributing to that. Uh, Already government focus is into that. And a country like India, where we are that we call it diversity, and then ekta, anekta, mekta, what kind of things we talk about and all. So even though their language things are different, their roots are mostly one. Roots are mostly is, you talk about the kind of, the Sanskrit is one of the things. Maybe Tamil is another one. Okay. So these two things, kind of roots are there. So we have to see now with this kind of understanding, you have to see this language technology into different way. What I feel. The way we are doing today is just to have a translation system or some kind of, creating a corpus, to deal with the various specialized, uh, like in the Hindi also, if you have to have the corpus has been created for the kind of the official languages for the scientific word and all. So we have to look into a very different aspect. Okay. Uh, how language is affecting the human cognitions and all. Uh, Maybe we have to discuss further on this, brainstorm onto this. But I still
Right.
feel language is a great work, and language is one thing which is the kind of, making us a kind of, a human being. So that is very important. Okay. Sometimes you don't see. Sometimes you don't exchange any words, even though we understand that. What is this?
Mm.
So this consciousness part is another aspect. We have to see that how
Yeah.
to capture those, the sixth
Mm.
sense we call it, sometimes these are the
Yeah.
very, very important
Yes,
aspect.
Right, right.
yes, sir. You have
Absolutely, sir.
already pointed out.
Visually, yeah.
You have already pointed out the sense making.
That's
There's a
very
one point you have pointed out, the sense making. It's a
right,
very
right,
important thing actually. In between the lines, what has been written, that
right,
should
right.
be our focus actually
This is
to extract these
right,
information, the sense making.
right, right.
It will be good, sir, if you can have further interaction later on in this
Exactly.
aspect.
Right.
Thank you, sir. Thank you very much.
Sir, there is one question from my side, sir.
Yes, yes.
Sir, as in the starting few slides, you talk about ethics and morality while developing the technology. So for the technological advancement, you said that ethics and morality is very important. But then at later stage and on the later slides, when you talked about various quotes, they talk about like there is a quote, Uddameni Siddhanti. So it says that eventually the result, basically my interpretation is that obviously when we are advancing and when we become experienced, we do think for for technological advancement for a cause which is larger than life, I must say. But during when we are youngsters, we always think about results and not about how ethical or non-ethical that particular thing is. So how do you justify? Because and there is a dichotomy when we talk, when we read Gita or for that matter any other Upanishad. Somewhere they say that what matters is the result. Somewhere they say that just the means are also as important as the ends. So how do we basically from the inception itself, when somebody like this is an organization, and when a youngster join this organization, what should we do to inculcate these kind of basically values and ethics in that particular person, whosoever is joining, or for that matter, the youngsters?
I tell you, just like, let's go back to the Indian culture system basically, and many people talk about a term called Sanatan basically, it's eternal. Sanatan is basically eternal system, and the scriptures which has been created by the kind of, great rishis and all, uh, that scriptures has been created in such a way and that you can comprehend the meaning as per your understanding and as per your experiences, what you have, what you are today. Okay. So what you are fetching the meaning out of a certain sloka from this Gita, Bhagavad Gita, and what Kunal is doing, both are the meanings they can give differently. And it is like, that's why I'm finding it very like we have seen a lot of Gita Gyan and all those kind of things. People are writing the books on the Gita and all kind of things. I would like to come out from those kind of aspects because I have my perception on Gita and I am giving to you, trying to influence you, where you have the capabilities. We'd like to develop that capabilities and we can comprehend, we can find the meanings in the Gita itself as per our kind of things and all. Suppose I have been trained as a kind of very good Gurukul and kind of system where ethical system in the family is very good. So whenever you design a system, uh, we always have that kind of a thought process in our mind that, okay, we'll see that. That suppose if somebody like Pune, we are developing one solution for the kind of uh, for the ACTS courses, we are trying to develop a solution for online exams and system. That time I had discussions on that. It should be there for everybody. Like somebody as a blind person can also use that particular system and all those things are already been there. So we're considering the bigger set of people. So when you have such kind of mindset which has been developed to you, you always think of a solutions which will be more ethical. Ethics again a kind of relative word. Then you have the come set of the people who are very business oriented. The goal objective is very, very business focused and all. Sometimes they compromise. Like you create a factories. Okay, a lot of CO2 emissions are there. Don't care about the environment. Don't care about the people around you, because your sole objective to work there is as a kind of as a to earn money and all. So these are the some of the kind of balancing aspects that we have to do. Of course, people have acted upon the policies, some kind of things are already been there, and SDG goals. We talk about sustainable development goals, 17 from the UN, which is actually guiding you that what should be your kind of anything you are doing. So what should be your objective? How you should go ahead with that? These are some of the aspects are there, but it's very, very challenging because you can't have everybody aligned on a kind of ethical setting. That's why we're talking about ethics. If everybody is aligned as a ethical wall, so there is no talk on the ethics because that is the de facto things. We don't have to, but we find a methods that the kind of larger audience may try to learn ethics, and that's why we're talking about can we technology be in force where we can imbibe the ethics within them. Okay, still we have to progress, we have to do certain aspects, but with the ethical aspect. And ethics is something again, uh, very simply we can mention that ethics maybe is that do something which will not harm anybody, anything, even the small uh, life on this earth should not be affected by the kind of uh, progress what you're trying to do. Something which is inevitable, कि अगर शेर को खाना है तो हिरन को ही खाना पड़ेगा. तो अगर वो ethical होगा, अगर खाना नहीं है तो that's not the ethics, that's a need. But there are certain needs should not अब मैं हिरण को खाना तो एक हिरण खा करके मैं 10 को तो नहीं मारूंगा, एक ही को मारूंगा. तो those are the some of the ethical aspect. It's a kind of layered approach basically, So maybe very difficult to completely analyze, but some of the kind of pointers I'm trying to put it here to think aloud on those aspects. Progression is needed, but you have to have a kind of framework that you should not go beyond that kind of things and all.
So, sir, do you think we should have a ethical code or ethical model for C-DAC here? And we should basically have a model developed around ethically developing technology in C-DAC.
See, something is in a conscious, okay? Something we have in a conscious, okay? So community conscious is already there. You are here today as a part of the C-DAC Patna team. Yesterday you were there with the Navy. Yesterday, then in between you are with the IIT. So there's some kind of aspect which is being here. Some kind of aspect which is being not. These kind of things have not been taught to you, not been told to you. You become the part because you have become the align your consciousness as per the kind of surroundings what you have. So what you see the ethics what you have right now. This is not any written rules. I'm not saying any written rules. Some of the do's and don'ts are there, but not in written. Written ethics comes within us. Okay, based on the do's and don'ts, uh, can't be enforced. No, it can't be enforced. It has to be some consciousness, awareness within you, which will bring the ethics to the system, and it becomes a part of the community. So when you bring what one aspect is that, and it automatically community get influenced out of that particular uh, things at all. So very, very philosophical aspect.
Thank you so much, sir.
Thank you so much, sir, for your insightful and thoughtful provoking session on the technology enabled philosophical aspects of consciousness and thinking. Thank you all for being such an engaged audience so far. We will taking a lunch break. Please feel free to enjoy the refreshments and being having arranged for you. We will continue the next session by
Wait,
4 p.m. onwards.
wait. You have arranged for everybody with Ashok ji also, and
Yeah, sure,
Devanshi
sir.
also for everybody.
Sorry, sir. Sorry, sir. Actually, this is a notification
You
for
all,
C-DAC Patna officials. Yeah.
you all have your own lunch, and send the bills to us.